It is Monday, Kings and Queens. Welcome to another week of Math 7. Today we're going to jump into Unit 1, Lesson 6a. Once again, it's Monday, October 5th, 2020, and we are going to be working on page 12 of our Math 7 Spiral notebooks. Our class norms for today, as usual, are that your cameras are to be on at this point. Your mic should be muted unless you're speaking to share with the class, and you are ready to learn and chat. Your materials for today, you are going to need your Math 7 Spiral notebook, your pencil, and there is a student companion for today's lesson in Google Classroom. Remember, you have to use the student companion if you want a grade for today's class. Also, let's make a note, if you are not submitting work, you are not getting grades. Progress reports are due today, and there are a lot of missing assignments. So moving forward, ladies and gentlemen, please make sure that you're doing all of your independent classwork assignments and the Google Classroom Student Companions. So let's jump right into today's lesson. So we're going to begin talking about representing proportional relationships with graphs. So we work with tables, equations, now we're working with graphs. So day one, introducing graphs of proportional relationships. So today our standard is 7.rp.2a. Our objectives are students will compare and contrast graphs of relationships, generalize that a proportional relationship can be represented in the coordinate plane by a line that includes the origin or by a collection of points that lie on such a line. We're also going to justify that a table and a graph represent the same relationship. Our mathematical practices are MP3, which is construct viable arguments and critique the reasoning of others, and MP7, which means look for and make use of structure. We're going to pause the video here so that you guys can copy down your objectives and your standards. Remember, we want to make sure that we're ready to take notes and work collaboratively. So once again, let's pause the video here so that you guys can copy this down. Okay, moving right along, let's look at our engagement activity for today. So for our engagement activity, ladies and gentlemen, we're going to work on actually plotting some points. This engagement can actually be found in your student companion, and it says to plot the points 0, 10, 1, 8, 2, 6, 3, 4, and 4, 2. What do you notice about the graph? So when you go into your student companion, you'll notice that it says to click the graph and select Edit to plot the points. So once again, in the student companion, the first thing that you're going to do to plot these points is you're going to click on the actual graph and then click Edit so that you can mark your points. Okay, so let's take about 3 minutes. We'll pause the video here to plot these 5 points. Okay. So now let's check our work. Hopefully on your student companion, this is the graph that you should have gotten. We also want to note, what do we notice about the graph? Hopefully you realize that the points line up so they can be connected by a single line. So starting at 0, 10, I could draw a line through all of these points. Okay. The line goes down. So if I'm reading this from left to right, the line is going down or it's decreasing. And every time the coordinate goes up 1, the coordinate goes down 2. So every time that the coordinate goes up, like if I go from 0 to 1, it also goes down 2. So let's talk about our goals for today. Our main goal is to identify how graphs of proportional relationships differ from graphs of other relationships. So the first activity that we're going to talk about is t-shirts for sale. And this is going to be our exploration activity that can also be found in your student companion. So our exploration is as follows. We know that some t-shirts cost $8 each, okay? And then we're given this table of X and Y values. So we want to know, what does X represent? We want to know, what does Y represent? And then we want to figure out, is there a proportional relationship between X and why. So I'm going to give you guys about 3 minutes of quiet work time to complete this portion of the student companion to answer those questions. What does X represent? What does Y represent? And then is there a proportional relationship between X and Y? Please make sure that you are typing this in to your student companion, and then we'll come back and share. All right. So let's go ahead and have about one or two, let's have actually three students share out their answers for each problem. We're going to pause again so that one person can share out the answer to question one, another will share out for number two, and then the third person will tell me whether or not this is proportional, and then we'll come back and check our work. Beautiful. Thank you guys so much for sharing. So for number one, when it says, what does X represent? X represents the number of t-shirts, okay? X represents your number of t-shirts. Number two, when it says, what does Y represent? So the Y column in the table, that represents the cost for the t-shirts. Remember, our first statement says one t-shirt costs $8. So the last one we want to know, is there a proportional relationship between X and Y? And the answer is yes. There is a proportional relationship between the two. You may also note that each time it's increasing by 8. So our constant of proportionality is 8, or our unit rate is 8, because for one shirt, it costs $8. Remember that base price is our constant of proportionality, or our unit rate. So let's take another 2 minutes to make sure that we're going to pause here, take about 2 minutes to answer the last two questions on the exploration activity of the student companion. It says, can we buy 7 shirts, 10 shirts? Can we buy a half a t-shirt? And then provide another real world example of a relationship represented by the graph. So let's just take about 2 minutes. We'll pause here because everybody's answers will be a little bit different, and we want to make sure that you get time to get the credit. Okay, moving right along. So we also want to talk about, what do you notice about the plotted points and the relationship to proportionality? So I would love for one or two of you guys to share, what are some of the things that you notice about the graph? Okay, so hopefully you also notice that this graph is increasing, and it isn't a straight line if I were to draw a line through it from the origin. So once again, the questions that were on the student companion said, can we buy 7 shirts, 10 shirts? Can we buy a half of a t-shirt? And then we also need to provide another real world example for the graph. So if we were to buy 0 shirts, then our graph will have the point 0, 0, which is the origin, right? So for 0 shirts, it costs $0. Now, could I use that to figure out the rest of the values? Absolutely. So remember, our graph consists of discrete points because only whole numbers of t-shirts make sense in this context. So whole numbers being like 7 or 10, a half a shirt wouldn't really make sense. However, if we were to connect the discrete points with a line to make the relationship more clear, even when the in-between values don't make sense, we can see that the graph passes through the origin, which shows the graph represents a proportional relationship. So if I'm able to draw a line through this graph and it actually goes through the origin, then that means that it is a proportional relationship. So let's try some things out. So we're going to do a little activity called, Is It Proportional? And I'm going to ask that you guys actually respond to each one of these in the chat. So let's start with our examples. So we have A, B, C, D, E, and F. So, ladies and gentlemen, remember, this says which graphs represent proportional relationships. In order for a graph to be proportional, it has to go through the origin. If I were to connect the points or the line that's already there, it has to go through the origin, which is 0, comma 0, and it has to be a straight line. So once again, the two requirements are it has to go through the origin, the line, or the points if I were to connect them, and it has to be a straight line. So let's take 2 minutes, and in the chat, I want you guys to tell me which of these graphs are proportional. We'll pause here. Okay, so let's check our answers. So graph A and graph F are the only ones that are proportional. So graph A and graph F are the only ones that are proportional. So remember, graph A has a line that goes through the origin 0, comma 0. So that one is obviously proportional and it's in a straight line. And graph F has ordered pairs that if we connect by one single line, it will go through the origin. So if I look at B, if I were to draw a line, it looks like a curve kind of, and it's not going through my origin. If I look at letter choice C isn't exactly starting at the origin. It was probably a tricky one, but it's not. D obviously does not start at the origin, even though it's a straight line, so that's not proportional. E isn't a straight line at all. So my only ones that are proportional are graphs A and graph F. So what do you notice about the graphs of proportional relationships? Hopefully you notice that their table here gives us what the constant proportionalities are for both. Remember, if I divide my second column by my first column, it'll give me my constant proportionality because these are all consistent for both. And remember, if I were to connect these points with a single line, they would go through the origin. So remember, if I were to take the points from the graph and put them in a table, if I needed to check whether or not they're proportional, I can do what we've learned how to do last week by finding the quotient of y divided by x to find the constant proportionality. So really quickly, what are the equations for these two graphs? Remember, we want an equation that's of the form y equals kx. So all we're going to do is replace k with the constant proportionality. So the first one, if I write something in the form y equals kx, the constant of proportionality is 8. So my my equation would be y equals 8x. So in the chat, let's see if you can do the same for the second one. I want something of y equals kx, and we're just replacing k for the constant of proportionality. So what would the equation be for the second table? So let's put that in the chat. We know that the first one was y equals 8x because the quotient was 8, and we're just replacing k. So what would it be for this second graph and table? We'll pause for about a minute so you can put it in the chat. Okay, so the answer is y equals 4x. The constant of proportionality here is 4 when I found the quotient, so the equation is y equals 4x. So here's another word wall that just gives us an example of when something is proportional. Remember, y equals kx crosses through the origin 0, comma 0. And y equals mx plus b. We don't need to worry about that just now, but this is non-proportional because it does not cross the origin at all. And remember, the origin is that point 0, comma 0. So let's just talk really quickly. So what does the graph of a proportional relationship look like? We talked about it again. We said there were two requirements. I would love for somebody to unmute and share what the answer is to this question. Thank you. So remember, the biggest thing that we want to remember from today's lesson is that the graph will make a straight line, and it also goes to the origin, which is 0, comma 0. So our goal for today, just to remind us, was that we wanted to be able to identify how graphs of proportional relationships differ from the graph of other relationships. Now, based off of everything we did today, I want you guys to do the evaluation activity on your own. So we're going to pause the video here for about 2 minutes, and I want you to go back to your student companion and complete the evaluation activity, which says which graphs cannot represent a proportional relationship. You're going to select all that apply and explain how you know. So which ones are not, this is important, which ones are not a proportional relationship, and explain how you know based off of everything that we learned today. So we'll pause here for 2 minutes so that you can complete the evaluation activity and then submit your student companion. Okay, thank you guys so much for completing that on your own. And then remember, hopefully at this point, you've already submitted your student companion so that you can get credit for today. So that pretty much wraps up our lesson for Monday. So let's talk about what your independent assignment is for today. You do have a Mobius math assignment, which is a video and a worksheet for class today. That is going to be due at 11:59 p.m. Remember, all of the directions are very well explained in Google Classroom. It'll tell you how to log into Mobius Math. For some reason, if it is not working for you, the actual worksheet will be attached as well. That way, you guys can do it on a separate sheet of paper if necessary. But the Mobius Math video and worksheet are all posted in Google Classroom. Other than that, I hope that you guys have a great rest of your day, and we will see you all tomorrow for Tuesday's class. Have a great rest of your day, guys.